Remember in our last lesson, we left off on this slide, comparing ionic compounds with molecular or covalent compounds. Today, our focus is to look at specifically our ionic compounds, how do we name them, and how do we write their chemical formulas. So remember that these compounds are made up from a metal and a non-metal, so a cation and an anion. They form a bond that is called an ionic bond through the transfer of electrons, and we're going to look at drawing them and representing them in different ways. Ionic compounds. Let's look at how they're formed using different diagrams. So remember that ionic compounds are formed through the transfer of an electron, or more than one electron. In this example, we have lithium, which is the Bohr-Rutherford diagram, and we also have fluorine, a Bohr-Rutherford diagram. So you can notice that in lithium's outer shell, or its valence shell, it has one electron that it wants to donate. Your fluorine has 7 electrons, so this electron wants a pair. So what's going to happen is your 1 electron from the lithium is going to get transferred and fill that outer shell in fluorine. So what you're left with is a lithium ion, which is lithium plus 1, and you're left with a fluorine ion that has gained an electron, which is fluorine minus 1. So because you have 1 and 1 of each, the formula for this is lithium fluoride, LiF. So that's simple. You can just count the number of diagrams that you have. Here we have magnesium and we have fluorine. So magnesium has 2 electrons in its Lewis dot diagram. And we can see that it will want to donate it to something else. Your fluorine here only has 7 electrons, so it needs 1 more in order to make it full. So magnesium is going to donate 1 of them to 1 fluorine, and it's going to donate the other one to another fluorine atom. So because magnesium has lost 2, it's an Mg plus 2 ion, and your fluorine, each of them, because there's only 1 of them, because there's 2 of them, each one is going to have a -1 charge, but you also have 2 of them. Okay, so we're going to multiply this by 2. So in our formula then, it's going to be magnesium, and because you have fluorine, you write 2 to represent fluorine. So it's magnesium fluoride there. So that's how you represent them using Lewis dot diagrams. If you forget how to read chemical formulas, here is how you're going to read it. So there's the chemical symbol. On the top right corner, we write the charge. Any kind of numerator or number that we see in the subscript is referring to the number of atoms that we need. So for example, if you see magnesium, okay, that's telling us that that's the charge. And in the formula, when we saw MgF2, that specifically is telling us the number of atoms of fluorine. So that's just a recall there for you. How do we actually write our chemical formulas? It's a very simple set of rules that we're going to be following, and here are the basic rules. Now it's called a crossing over or a crisscross method, and this is specifically for ionic compounds that we're going to be doing over the next few days. So first thing is write the element symbols that you have for each element, write their charges in the top right corner, then you're going to cross the charges of each element onto the bottom right subscripts of the other elements. But we're going to ignore the signs. And then finally, we're going to see if we can reduce to the lowest common denominator. So let's try these rules out. So let's try combining lithium with fluorine here. Okay, so you're going to start off with your metal first, and then your non-metal. So metal plus non-metal. That's always the order. So first thing is write your elements out. So I know lithium is Li, and I know my fluorine is an F. Then you're going to use your periodic table and remind yourself of what the charges are for them. So I just filled out my periodic table here with the charges right on the top. So lithium, because it's in the first column, it has 1 valence electron. It's easy to lose that one, so it's going to be a +1 charge. Your fluorine, because it's in the 7th column, it has 7 valence electrons. It's easy to gain 1 electron, so it has a -1 charge. What you're going to do next is you're going to crisscross your charges. So this one is going to come over here, and this one is going to come over here. So our new formula is going to look something like this. So lithium and fluorine. We ignore the signs. The only problem is, though, whenever you crisscross, we don't write subscripts of 1. So this is actually incorrect. What you should write is lithium and fluorine. Okay, so by writing the name or symbol, we are indicating that there's already one of them. Let's try another practice. So here we have magnesium reacting with fluorine. Again, identify the symbol and what charge it has. So magnesium is in the 2nd column, so it has 2 valence electrons. It's easy to lose those 2, so it's a +2. So magnesium would have a +2, fluorine would have a -1. So what you're going to do, and if it helps, you should draw out the crisscross. Okay, so that the 1 is going to come down here and the 2 is going to come down here. So what that looks like is magnesium. We don't write the 1s. We only write anything greater than a 1. So it should be F2. Again, don't write the 1s. So that's our final answer. Let's try another one again. So calcium reacts with oxygen. So you're going to find calcium. Calcium is in the 2nd column. It has 2 valence electrons, so it should have a +2 charge. And oxygen is in the 6th, or has 6 valence electrons, sorry, and it should have a charge of -2 because it's easy to add 2 to make 8. So first step is writing out the symbols. And oxygen is an O. So calcium should have a +2 and oxygen should have a -2. Again, you're going to crisscross your charges without writing the signs. So our new formula, you would think, would look like CaO, Ca2, and O2. The only problem is we want to remember that last rule. So the last rule is that you want to reduce the subscripts, okay, by dividing by the greatest common divisor. So both of these can be reduced by 2. So this would be incorrect. We want to reduce and divide by 2 for both of them, so we're left with 1 and 1. So this is our final answer. So they don't have to disappear for both of them, but you want to reduce as much as possible. How do you name our compounds now? So that's called nomenclature. So what is nomenclature? It's a system for naming or classifying our compounds. Why is this important? Because it's going to identify our specific reactants that are involved in order to produce a specific product, and also because it's a universal naming system. So how do we name our type of ionic compounds that we're dealing with? So remember that you are naming your metals first and then your non-metals. So here we have how you change the names. So the cation keeps its name, so that's the metal. And what you're going to do is you're going to change the non-metal's name. So you're going to change its ending to IDE. Very simple. Metal keeps its name, non-metal needs to change its name to IDE. There are some exceptions to the IDE ending when you're dropping the last part of the name. So it's not carbonide, it's carbide. It's not nitrogenide, it's nitride. And it's not phosphogenide, it's phosphide. Oxygen is oxide, sulfur is sulfide, fluorine is fluoride, chloride, bromide, and iodide. So keep those in mind as you are naming. So let's practice naming these specific examples. So remember that your metals are always written first. So these are our metals. So identify your metals. So I have sodium and I have chlorine here. You don't have to do this part, but basically what you're going to do is by identifying them, you're going to change the chlorine now to chloride. So metal keeps its name, the non-metal needs to change. So notice I'm only changing the non-metal name. Looking at example number 2. So you have beryllium and you have oxygen as your non-metal. Okay, so we're going to change the oxygen. So if you remember correctly on the previous slide, it's oxide. So this one is going to be called beryllium oxide. So notice our metals are staying the same. We're not changing the metal names. So here we have magnesium and bromine. So we're going to change our non-metal name. So magnesium stays the same, bromine changes to bromide. And last example, we have a lithium and a fluorine. So we change the fluorine ending, the non-metal, to lithium fluoride. So again, you don't need to do this. I just need to be able to see the final name in your naming system there. So take a minute, pause the lesson, and see if you can do these two on your own. So hopefully you saw that iodine is the non-metal, so that's the one that you're going to need to change. So the name for this is magnesium iodide. Okay, so changing the ending. This isn't a trick question. This is not our metal, so you actually need to switch their spots. So the calcium needs to come first, and then the nitrogen. And the nitrogen is the one that you need to change. So it's calcium nitride. Okay, this is the correct name, not the other way around. So it's not nitride calcium. So you have to remember that the metal always comes first. So hopefully now you can go and practice on the worksheet.